Hi class, welcome back. We're going to be going over lesson 2 today. This is a two-part lesson, so first part is going to be lesson 2, and it's going to be talking just about the ratios and how to find them, and then the second part is just basically going to be how to apply the stuff that we've already learned to practice. Okay? So before we get started, just going to go over what the learning goals for this lesson are. The learning goals for this lesson are as follows. You will know how to label the sides of a triangle, so you'll know what the opposite is, what the adjacent is, and what the hypotenuse is. You'll know how to draw in angles of elevation as well as angles of depression. And you will know what the primary trig ratios are, so SOHCAHTOA, and how to use SOHCAHTOA to find the missing angles in the triangle, as well as how to find the missing side lengths. So we're just going to dive right in. A trigonometric ratio is a comparison of two sides in a right triangle. This is super important here. You can't use them in non-right triangles, right? So you just got to make sure you know that. Can't be a non-right triangle. That's when you'd have to use something like cosine law and sine law, which we'll learn in our next lesson. So that's important. Okay? So trigonometric ratios associate the measure of an angle with the ratio of two sides. So we'll go into what that actually means a little bit later. But before we get started, I just want to say we're going to be naming triangle sides today. So this is a really important skill that you need to know. The one thing you need to realize is that triangle sides are named in reference to the angle that we're measuring. So if I'm looking for angle A, my opposite and adjacent are going to be different than if we're looking for angle B, which would be up here. Okay? The hypotenuse always stays the same because it's just the diagonal line. So I can just go in and put my hypotenuse. And from now on, I'm just writing it down right the first time. But after this, I usually just write it as hype, like that. Okay? So we have the hypotenuse, which always stays the same, it's just that diagonal line. So if I'm looking at angle A, the opposite angle is going to be the one that is directly across from it, right? So the side that is directly across from it, so that's the opposite, right? I'm just going to go back in here. I don't know why that keeps changing. Opposite, right? And then the adjacent is going to be the one that kind of sits with it. It's the angle that, or the side length that actually comes in and makes that angle, right? So it's right beside it. So that's the adjacent. And that makes sense because if you think of this logically and what each of those words means, right? Hypotenuse we know is just always the longest side. We remember that from when we did a squared plus b squared equals c squared. Opposite is the one that's looking across from it, right? And then adjacent literally means to be sitting next to someone. You're sitting adjacent to the person beside you. So that makes sense that it would be the one that's right beside the angle. Okay, so we're going to do the same thing with B. So now if we're looking at a different angle, we're looking at B, our opposite and our adjacent are going to change. Our hypotenuse stays the same, so I'm just going to write hype. Right? Our opposite in this situation is going to be the one that's kind of across from it. So right there, right? So this is going to be our opposite side. And our adjacent side is going to be the one that's kind of like lined up beside it. So our adjacent. Okay. And then going from that, we're going to be talking a lot about angles of elevation or angles of depression. So in the Greek alphabet, usually we use like theta, alpha, beta to describe angles. We consider something called an angle of elevation and depression. So I'll start off with what an angle of elevation is. So say this is your horizontal line right here. I'm just going to correct it and make it horizontal. So this is our horizontal line right here. If from that or horizontal line, our angle is looking upwards, right? So it's opening up towards whatever is on top or towards the ceiling, right? That's going to be an angle of elevation, which makes sense. Elevate means to lift. So this angle is kind of lifting up from the ground upwards, right? That's an angle of elevation. On the flip side, if I have an angle that's on this horizontal line and it's actually pointing downwards, so I'm just going to take this angle right here and say this angle is going to open up downwards, right? This angle right here, right? Because it's on a horizontal, it's coming downwards, it's going to be an angle of depression. And that makes sense because depression literally means to be down, right? So going downwards. So if you think about what the words actually mean, the depression one will come down and the angle of elevation will elevate up. Okay? So then we have our primary trigonometric ratio. So I don't know if you remember this from grade 10. SOHCAHTOA was a really big deal in grade 10. We're going to be bringing that back. SOHCAHTOA is basically just the acronym that we use to remember what the sine ratios, cosine ratio and the tangent ratio are. We remember that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and then tangent is equal to opposite over adjacent, right? When we're looking at different angles, we're going to have different opposites and different adjacents. But say we're looking at angle A here, we're going to name that theta, right? My opposite will be the one that's directly across from it, which will be up, right? My adjacent will be the one beside it, so that'll be the 4 centimeters, and the hypotenuse always stays the same, right? So in this situation, if I'm looking at the opposite over hypotenuse, right? I'm just going to go in, I'm going to say, all right, angle A, my opposite is 3 centimeters, so it'll be 3, and my hypotenuse is 5, so I'll be 5, right? Same idea. Try doing adjacent and opposite, try doing cosine and tangent by yourself, just by looking at the diagram. And then if you want an extra challenge, try doing what it would be for B. So I'm going to do B in orange for you, but you also try doing what it would be in B so that you kind of get an idea of what the different angles will have. That's why the angles are not the same, right? Because their ratios are different. So pause the video here, try going through it by yourself, and then come back and watch the solution. Okay, so hopefully you paused and had a chance. So let's look at our adjacent over hypotenuse. So we have adjacent, which was 4, and our hypotenuse, which was still 5. And then we have opposite over adjacent, so our opposite is 3, and our adjacent is 4. And that'll be our angles for theta. If we wanted to find them for our B angle, so I'm just going to write A up here. If we want to find them for our B angle, we know that sine theta is equal to opposite over hypotenuse. Our opposite now changes because if you look at what's opposite, it's actually this line over here. So our opposite would be 4, right? And if we look at what's adjacent, it's actually this 3. So now our ratio is, 4 over 5. Hypotenuse is still 5, right? Because that doesn't change. So 4 over 5. Our cosine theta is going to be adjacent over hypotenuse, so 3 over 5, right? And then tan theta is going to be opposite, which in this situation would be 4, over adjacent, which in this situation would be 3. So they're similar, but the numbers have changed around a little bit. All right. So moving on. It says find the unknown value of each of the following. So it's cool, like, yeah, we can find the ratios, but what's the point? This is the point. So when you're going about to solve these problems, the first thing I would suggest is actually go in and say, all right, what are we looking for? What am I actually looking for in this situation? And just go label your sides. So I know this is my hypotenuse. I know this is my opposite. Or sorry, this is my adjacent rather. Because the angle I'm given is 38, so that's my adjacent. And then my opposite is over here. Right? So if I go back and I look at this, I'm looking for x. I want to find out what the adjacent side is. I have an angle, I have the hypotenuse, and I have to find the adjacent. So in this situation, I'm just going to go back here and be like, okay, if I have the angle, so I have theta, I have the hypotenuse, and I'm looking for the adjacent. Cosine makes the most sense to use, right? So let's go down and use cosine. So I'm going to say, all right, cosine theta, which is our theta in this situation is 38 because that's our angle, is equal to adjacent over hypotenuse, right? That's the ka in SOHCAHTOA. So I'm just going to leave the cosine 38 because for me personally, I like to deal with that after. Because it just gives me the most accurate results to do everything all together. My adjacent, I don't know what it is. It's x. My hypotenuse, I know is 12. Right? So if I want to get x by itself, I can just multiply both sides by 12. And see, this is why I didn't want to just go in and do cosine 38. So now if I go to my calculator, and I'm just going to show you on my screen what it would look like. I have my own calculator that I use that I'll probably use from now on. But this is just to show you what it would look like. So my question is asking me what's 12. So I'm going to put in 12 times, right? That's why I use that little dot button. Cosine 38. And just make sure you put a bracket at the end of it and then you click your enter. And I know that my answer is 9.456129. I'm just going to do 9.456 and that's going to be my answer. Right? So I know that x is equal to 9.456. And it's important, if you didn't get that number, it's probably because your calculator is not in degrees. So make sure that it's in degrees. And if you're like, I don't know what that means, basically if you reset your calculator, it will show up in degrees. But at the top of your calculator, there should be an option that says DEG. So if you change it to radians, you'll notice that it actually changes. For the purposes of this course, you want everything in degrees, not radians. Okay? So if you're getting 11, it's probably because your calculator is in radians. So just make sure that you switch it over to degrees. So I suggest before you ever do a test or a quiz or even an assignment, just double check and make sure that it's always in DEG. There should be a little DEG in the side of your calculator in the top corner. All right, moving on. I'm going to have you try doing this one by yourself. It's a little bit more complicated because x is actually the hypotenuse here, which means it's in the denominator, so you need to do a little bit of cross multiplying. But pause the video here, try to walk through it yourself, and then we'll move on and try to do a couple of other problems before we finish up. All right, so I'm going to have us just go through this one. Hopefully you pause and try to go through it by yourself. So here we're given 42. So we have some sort of an angle. We're given the opposite side. We want to find the hypotenuse. So I'm going to go back here and be like, okay, which ratio can I use the opposite and hypotenuse in? It's obviously sine. So I'm going to go in, I'm going to say, all right, so sine theta is equal to opposite over hypotenuse, right? That's the SOA part of SOHCAHTOA, or the SO part of SOHCAHTOA. So I know what my theta is. I know it's 42. I know what my opposite is. It's 13, right? And always write your units. Sorry, my bad. I didn't do that. So x is equal to 9. That one. So I know it's 13. And I know my hypotenuse is x. So here, if I assume that this is over 1, which it is, I can just cross multiply, right? So I can cross multiply here, cross multiply here. So I'm going to get rid of that x in the denominator. I'm going to be left with sine 42 multiplied by x equals 13 times 1, which is just 13, right? I want to get the x by itself, so I'm going to divide by sine 42. Divide by sine 42. And I'm left with x is equal to 13 divided by sine 42. And I'm just going to go in and throw that into that same calculator I was using. So I'm going to say, okay, clear all. 13 divided by sine 42 is going to give me, and I'm going to just close my bracket, is going to give me 19.428. So I'm just going to go back in. So I know x is equal to 19.428, or you can just write it as 19.4. Okay. Perfect. So we're going to go in and I'm just going to show you how to use a calculator to solve some of these, especially these ones over here. But if you want, you can try doing these by yourself if you kind of remember from last year. But I'm just definitely going to go back and show you how to do this again. So for something like sine 170, you can just go back into this calculator. I'm just going to clear it. You can just click sine 170, close the bracket, and press enter, and you're going to get 0.1736. That'll be your answer. Right, so 0.1736 is what sine 170 is equal to. Same idea with cosine 56. You're going to go in here and make sure it's in degrees. You're going to say cosine, and then you're going to say 56, right? And then you're just going to enter it into your calculator, and you should get 0.5592, right? So I'm going to go in and I'm going to write 0.5592. This is where it gets a little bit tricky. So what most students want to do here is you want to divide by sign, right? So I'm going to go and I'm going to show you what that looks like. That's what most students want to do. So I'm just going to go in here and I'm going to show you that that doesn't work. So it's 0.9848 divided by sine, and like you get this arrow over here, right? It's because it's an error. You can't just divide by sine. What you need to do to get rid of the sine is actually what we call sine inverse, right? So just like square rooting is the opposite of squaring something, the opposite of sine is not dividing by sine, but rather doing sine inverse. So you would do sine inverse, and I'm only going to do this once because honestly it's such a pain to write, sine theta, right? And then the sine inverse gets rid of this sine, and so whatever you do to one side you have to do to the other, so it'll be sine inverse on this side times 0.9848, right? And now if we go into our calculator, you'll see, I'm just going to clear this again, we have over here you'll see the sine to the power of -1. That's sine inverse. And on some of your calculators, it's probably the button just above the sign. So if you click second function, it should show up there as well. That's what the FUNC means. It just means function. So on most calculators, if you click the second F button and then hit the sign, it'll show up as inverse sine. So if we do inverse sine now of, I'm just going to go back to my main button here, 0.9848, sorry, my 4 button does not want to work, 48, right? We're going to get 79.9974. And that's how that would work. So you can say that that is roughly, so then I know theta is 79.9974. I'm just going to round that to the nearest degree, so it'll be 80. Okay, so try doing tan on your own. Sorry there wasn't enough space that way, but try doing tan on your own and we'll take that up together before we move on. So pause the video here, try doing it yourself. All right, so we're going to take up tan, right? Same idea with tan theta. Right? You're trying to find what that angle is. You can't just simply divide by tan. You need to do the opposite. So the opposite of tan is tan inverse, which is just tan to the -1, right? Times tan theta. That'll cancel that out. And then whatever you do to one side, you have to do to the other side. So it'll be tan inverse times our number of 1.1357. So again, if I go back here, right, I'm just going to go to tan inverse. So I like to clear everything first, tan inverse, and then I'm left with 4, sorry, I'm doing 1.1357. Personally, I dislike this calculator because it's not as nice as a regular one, but I can't show you my regular calculator because I don't have it on screen. So this is tan inverse, so it's going to be 48.363. So I like to just round to the nearest decimal place or to the nearest whole number. So I know theta is going to be 40. Oops, sorry, it was 48. So it'll be 49. And always put the degrees there. So I know theta there is 49. So that's how you find the angle if you're given some sort of a ratio already, or if you're given decimals. You might sometimes be given a ratio and then you have to find the decimals, or in this situation, you might just be given a triangle and it's asking you to find the side. You can find the value of x to the nearest tenth of the side. We've kind of already done an example like that. And in this situation, you can actually have those different side lengths, divide them, and find the angles as well. So how to solve this if you have the angles, right? If you have the angle and you have one side and you're trying to find the side opposite or adjacent or the hypotenuse, you can do that as well. So let's just try doing this one. Try doing this one by yourself. We've kind of already done a few examples of it. And then come back and look it up. Okay. And I'm just going to use my calculator now because the switching back and forth can sometimes disrupt the flow of the lesson. But you know how to use that calculator. So it says, example, solving for the unknown side. Find the value of x to the nearest tenth, which is just one decimal place. And remember, if units are given, they must be stated in the answer. Always, always remember that. I'm just reading from your note here. Okay, so I'm going to go here and I'm going to say, okay, this is my angle, the 43. I'm looking for something that will give away what type of ratio I should use. So I have the opposite, right? And I have the adjacent. And so if I go back and I look at my SOHCAHTOA stuff, I'm just going to type it out. So this needs hypotenuse, I can't use sine. This needs hypotenuse, I can't use that. I can use tan, right? Tan doesn't need a hypotenuse, and I don't have a hypotenuse. I have opposite and I have adjacent. So I'm going to say, okay, so tan, the angle is 43, is equal to opposite, which I don't know, which is just x, over adjacent, which is 6, right? So then I'm just going to go in and do my math. I'm going to get rid of the 6 on both sides by multiplying both sides by 6. Right, so then I'm going to have 6 times tan 43, right? So tan, and you don't have to rewrite this step out. I just like to have everything all neat and clean, is equal to x. So let's do that. Tan 43 is going to be like 0.932515086. I'm going to leave that answer in my calculator as I move on and multiply it by 6, right? So I'm left with 5.595, and it says to the nearest one decimal place, so I'm going to round that to 5.6 is equal to x. I am given units here, so I'm going to write those in. So it's 5.6 centimeters is equal to x. Cool. So try doing 2 by yourself. I hope that you did try doing this by yourself because they're very similar to the other ones. So I'll take this up. So hype is there. The angle is right here, so the opposite will be here, right? And then this is the adjacent. I don't have the adjacent side, so I don't even need to write it in. So I know I have to use op and hype, and that I know is my sine, right, from SOHCAHTOA. I just go back and look at it, opposite and hypotenuse. So sine 61 is equal to opposite over hypotenuse, right? So I'm going to do, okay, I'm just going to go in and plug in my numbers. So I know my hypotenuse is x, because I don't know what that is yet, and my opposite value is 12. Right, I'm going to multiply both sides by x to kind of get rid of the x in the denominator because it's messy. Right, so I'm left with sine 61 times x is equal to 12. I want to get that x by itself, so I'm going to divide sine 61. Notice I can divide sine if there is a number after it. So I can divide sine 61. I can't just divide sine 0, like without anything in there. Okay, and then I have sine 61 over here. And then I do x, 12 divided by sine 61 is equal to 13.72. So it says again, first decimal place. I'm just going to write that, and it's in meters. So that is my answer. So it says, if you know the two sides of a right triangle, the sine inverse, the cosine inverse, or the tan inverse keys on your calculator can be used to find the degree measure of the angle in a triangle. Just as taking the square root of a number is the inverse or opposite function to squaring the number, sine, cosine, and tan are the inverse or the opposite function to sine, cos, and tan. So it's basically like, you know how you do subtraction to get rid of addition, you do division to get rid of multiplication, you square root to get rid of a squared, you do sine inverse to get rid of sine, you do cos inverse to get rid of cos, and you do tan inverse to get rid of tan. So we're just going to move on to example 4, and that's our last example for this lesson. It says, solve for the unknown angle. So find the measure of the indicated angle to the nearest tenth of a degree, which is just 1 decimal place. And more often than not, I will just ask for 1 decimal place. If it's an angle, I might just even ask for the whole angle. Just be careful to read that carefully. Okay, so we're just going to see what angle are we looking for. So it's always going to be the one that's kind of labeled, right? So in this situation, it's theta. So we're looking for theta. So looking at theta, let's see what we have. Do we have the opposite? No, I don't have any information about the opposite. I do have the hypotenuse. I also have my adjacent side right here. So if I have the adjacent and I have the hypotenuse, I know from SOHCAHTOA, I always like to write it out. SOHCAHTOA. Sine is out of the question because I need the opposite. Tan's out of the question because I need the opposite. Cosine works because I have an adjacent and I have a hypotenuse. So let's do cosine. Cosine theta is equal to adjacent over hypotenuse, right? So cosine is equal to, I don't know why it keeps doing that. Cosine is equal to, the adjacent number is 3, the hypotenuse is 10. So you can do one of two things. You can go into your calculator and do inverse cosine of 3 divided by 10. Or you could just do the 3 divided by 10 first, right? So I like to do that. And I know 3 divided by 10 is just 0.3. And then I go in and I say, okay, now I want to get rid of the cosine. So I'm going to do inverse cos. And whatever I do on one side, I have to do on the other. So I'm going to multiply this side by inverse cos, and I'm left with, and I'm just going to show you in the calculator here how that works, right? So then I'm left with inverse cosine 0.3, close that bracket, enter. So it's 72.54, right? And it says only 1 decimal place, so we're going to leave it as that, 72.5. So it says 72.5 degrees is my theta, because I got rid of that. Cool. So try doing 2 by yourself. Just pause the video here, and then I will come back and solve it for you. All right. So welcome back. The theta we're looking for is here now at K. So first things first, I'm going to see, all right, do I have the opposite? Yes, I do. Do I have the hypotenuse? No, but I'm just going to label it just in case. And I have the adjacent. So if I go back and I look at this, I can't do that because I need the hypotenuse. I can't do cosine, I need the hypotenuse, but I can do tangent because I have the opposite and I have the adjacent, right? So let's go in and use tangent. So I know tangent theta is going to be equal to the opposite over the adjacent, right? And if while you're doing your homework, you need to write these down somewhere, like go for it. That'll really help you. Is equal to 9, right? Divided by 6. And then I like to put that in. 9 divided by 6 is 1.5. So then tan theta is equal to 1.5. And obviously I have to multiply by inverse tan on both sides. Tan inverse multiply by tan inverse 1 here, right? And you always just need to put it in so that it looks like this. It'll go in as tan inverse and then 1.5. So theta is equal to, and if you put that into your calculator, you should get 56.3 is your theta. And that's the answer. And that's it. That's lesson 2, part 1. I'm going to post lesson 2, like the same. I'm going to post lesson 3, which is part 2 of this lesson, in a different video. Thank you.